Hey guys, this is your trainer Anirudh Chhillar. So I'm back with another video of EIGRP. I hope you're learning in a good way and in good pace. Let's go.
Now let's go for fast reroute here, FRR. That is very new concept in iOS 15. Fine. Show IP interface brief, that's fine. Show IP route, it is performing equal cost load balancing for all 60 prefixes, right? Now what I want to configure this route as a successor. And it will become it should be feasible successor. So what can we do to configure this route as a feasible successor for R1 for 60 prefixes? Tell me. See, I want to configure YR2 as successor, YR3 I want to configure it as a feasible successor. Right now R1 is performing equal cost load balancing. So do one thing, increase some delay on FA0 by 1 of R1, so that the overall delay via R3 will be higher than via R2. It's not it. So you do one thing, move on R1, and on R1 on its FA0 by 1, because by default delay is do show interface FA0 by 1. Let me show you. Default delay is what? 100 microseconds. So make it 1000 microseconds. So interface FA0 by 1, delay 100, because your delay will always be configured in the tens of the in the multiple of tens. This is not the delay for EIGRP. This is the delay of the physical interface itself. This is not, here you are configuring delay and bandwidth for interface, not for EIGRP, right? However, EIGRP will be using this delay for its calculation. That's the different thing. Show IP route, you see, its best path have become via R2. But if you check its topology table, show IP EIGRP topology, check it out. It is having feasible, as you can see here, because the advertised distance of feasible successor must be lower than to the FD of successor, and which is there. See, the advertised distance of backup path is lower than to the FD of successor. You can see. So it is fulfilling the condition of becoming feasible successor. That is why for all 60 prefixes, this 13.1.3 have been configured as a feasible successor. Now let me show you. Show IP route 60.1.0 is its routing table, especially this RIB, having an information about your feasible successor? Tell me. Is routing table of EIGRP having an information about your feasible successor, about your backup path? No. Show IP SEF 60.1.0 detail. Does it have any information about your feasible successor, your SAF table? Tell me. So in case if your successor goes down, just try to understand. In case if your successor goes down, then EIGRP will define its feasible successor as a successor, and then after those routes will get installed inside its own routing, and then routing table will update SAF table fib. It means still it will take some more time, is not it? Hello?
Yes.
Try to understand. It will take some more time. So latency will be high. To reduce this latency, what can we do? We can enable fast reroute. We can enable this feature of named mode EIGRP, fast reroute. What happens after enabling actually fast reroute? That your routing table as well as SAF table will also come to know about your backup path. Are you getting my point or not? Your routing table as well as SAF table will also come to know about your backup path. Right now they do not have any information about their backup path. Only EIGRP is having this information. Are you getting my point or not? We saw that routing table was not having any information about backup path. Even SAF table was also not having any information about your backup path. And of course, if routing table do not have any information about backup path, then how will it be possible for SAF table to have that information? Because SAF table means it's a copy of RIP, routing table. So move on R1. To enable this fast reroute, router EIGRP CCIE address family IPv4 autonomous system is 100, then go to topology base, and then here you are having fast reroute. For per prefix, yes, and then for some specific routes or for all, that option is also available, that you want to enable fast reroute only for some specific prefixes. So if you want to enable this feature only for few prefixes, then use route map. In route map, call only those prefixes for which you want to enable fast reroute. But if you want to enable fast reroute for all prefixes, then say all. Now, after enabling fast reroute on R1, show IP EIGRP topology will remain same. Topology table will remain same. There is no problem at all. You see, there is no change. Is there? But if you say show IP route 60.1.0, it's not it. So this time it is having information about your repair path. This is called fast reroute. Not only this routing table, even SAF table is also having this information now. Of course, but here it will not show you details of routing table. Have you understood it? The uses of fast reroute. Previously, the information of feasible successor was not available inside the routing table as well as SAF table. But after enabling fast reroute in EIGRP, now routing table is also having this information that it is also having one repair path, alternate path. Even SAF table is also having this information that it is also having one repair path. So whenever your primary link goes down, primary path will go down, then it will immediately shift your traffic onto repair path. Understood or not?
Yes.
For sure. Great. Redistribution in EIGRP. Where? Is locally configured IP address on /32. In iOS 15 there will be two entries for one interface now. As one will be for L, one will be for C. C is connected network. It will show you network ID, whereas under L it will specify that IP address only which is configured on your interface on /32. Now on R1, let's configure k values metric weights in EIGRP named mode. I mean that how can we change them, right? So to change k values in EIGRP named mode, it's very simple. Router EIGRP Cisco, sorry CCIE, address family IPv4 autonomous system 100, and here only you can say metric weights. Even you are not required to move under topology based mode. So metric weights toss is by default 0, same as previously. Then here you are also having one another option. Let's say I just wanted to change k1 only. So type k1's value and press enter. Previously it was mandatory to specify all k values before pressing enter. So they have also added this feature in this iOS now. So k1, let's say it is 1, k2, 1, k3, 1, k4, 1, k5, 1, and also it is asking about, you see, k6. Previously it was not there. Is not it? So in this way you can change your K values, metric weights. Understood it completely now? Fine. Apart from it, you are also having neighbor command here. Inside address family mode only. You are not inside topology base mode or AF interface mode.
Yeah.
You are inside address family mode only. So here you can also define your neighbor statically. Let's say that you want to configure neighbor statically. Then you can say 12.1.2 and then exit interface. And exit interface is what? Fast Ethernet 0 by 0. It will break neighborship now. Because if you have configured your neighbor statically on one end, right? Do one thing, move on R2 now. Say neighbor. Fine. Again neighborship will come up. See, it have came up now. So in this way you can configure your neighbor statically. I taught you that how to perform summarization. I have taught you that how to configure route filtering and all these things, right? Then do one thing, you can also move under interface mode as well, and then you can press enter. So here you can configure authentication, bandwidth percent is also there, is not it? Then hello interval is there, hold time is there, next hop, split horizon is also there. So if you want to disable split horizon here, if you are required to disable split horizon, and if you go to your physical interface this time and you say IP, it won't take place. This command will not take place because right now you are running named mode, right? Even let me show you. Do show IP IGRP interfaces detail. So here you will see that split horizon is still enabled. However, we have disabled it externally. So now to disable it, you do one thing. Router EIGRP is what? And then address family IPv4 autonomous system is what? 100. And then go to interface mode FA 0 by 0 and then say no. That's very simple. Now go back to show IP IGRP interface. You see, sorry, detail. So you will see that split horizon has been disabled now. And if you remember that, then I also taught you the uses of no next hop self command as well. So router EIGRP CCIE address family IPv4 autonomous system is 100. AF interface fast Ethernet 0 by 0 to enable split horizon. Once again, split horizon to disable next hop self, because by default next hop self is enabled. So say no next hop self. That's it. To enable it, next hop. It's very simple. Then previously, because previously it was also required to specify your AS number as well. But this time you are already inside the AS. That's why you are not required to specify your AS number. So in this way you can implement EIGRP in named mode. Next topic is here. Like the problem with EIGRP is like this. For an example, if there are two routers R1 connected with using a switch, you allocated IP address here 12.1.1, you allocated here IP address 12.1.2. Now this link has gone down. So R1 will take at least 15 seconds to identify this failure, this link failure, is not it? Because the hold down timer is what? And EIGRP can break your neighborship immediately if its line protocol goes down. In that case, I mean, if your line protocol goes down of that interface on which it is having one neighbor, then it can break neighborship with that neighbor immediately, right? In that case, it will never, I mean, it does not wait for the expiration of hold down timer. But this time, in case of Ethernet, of course, line protocol will never go down in between R1 and of course on R2 as well. So they have to wait for entire hold down timer. So first of all, they will let your hold down timer expire, and then after, I got your point. Then after 15 seconds, they will break neighborship and they will come to know that okay, this link has gone down, and that's too much. 15 seconds are too much. Means that your entire data will get dropped for next 15 seconds. So there will be an outage in your network for 15 seconds. That's too much. To solve this problem, we are having a concept of BFD actually here. Bidirectional forwarding detection. You can enable BFD in between R1 and R2, and BFD sends hello packets. I mean, inside BFD, I will teach you this BFD itself. This is a separate protocol actually, and after enabling BFD in between two routers, they start to send hello packets to each other. I mean, BFD hello packets, and the hello interval will be kind of milliseconds. Hold down also can be configured like in milliseconds itself. So in case if this link goes down, then BFD neighborship will go down immediately. And then we can bind this BFD with EIGRP. Are you getting my point or not?
Yes.
First of all, we will require to enable BFD in between these two routers, and then further we can bind this BFD with. So in case if BFD lost its neighborship, that EIGRP will also break its neighborship immediately without doing wait for the expiration of hold interval. Have you understood it or not? So in this way you can enable BFD. I mean, for this purpose you will be enabling BFD in EIGRP. So you do one thing, move on R1. You are already under interface mode. As I said that all these commands can be configured. So inside it you are also having BFD. That's it. To enable BFD in this way you can enable, but first of all you have to enable BFD globally. Are you getting my point or not?
Yes.
First of all you have to enable BFD globally, and then after you can associate that BFD with EIGRP. Because BFD is not running on this device, that is why it is not possible to configure it here. Have you understood it or not?
Yes. So what is the command?
What?
What is the command
To configure BFD. I said that it is a separate protocol. I'll be teaching you this BFD separate. But this time I just wanted to tell you the use of this command, and then bandwidth percent, you know very well that what is the use of this command, right? And the default is nothing over there. Default summary address, default authentication, hold time. If you want to configure default hold time, say hold time, and then default hello interval. So IP, yes, it is there. But here also you are having, see, now hold down and hello timers have been configured as default timers. Understood or not?
Yes.
Now, after going through all these practicals in named mode, let's talk about stub routing. Because in previous class I told you that how stuck in active state is dangerous for your network. Because once your router has moved into stuck in active state, then it will break neighborship with that neighbor, right? It will reset the neighborship. So if you want to prevent your network from stuck in active states, what can you configure in your network? Use summarization as much as possible, so that if any one of the prefix goes down, then other routers will never come to know that okay, this network has gone down. Second, you can also disable active timer, so that your router will never move into stuck in active state, which is by default 3 minutes, right? By default your active timer is what? 3 minutes. Means that if your router becomes active for 3 minutes, then it will stop, I mean it will announce itself in stuck in active state. But it's not possible like to configure summarization everywhere, and also it is not possible to configure, I mean to disable your active timer. Finally, we are having a concept of stub routing here to prevent your network from stuck in active states. So for that purpose here we are having that stub routing. And now you know very well, because in CCNP I hope that you have already done this practical, that how to configure stub routing, right? Like if you configure any router as a stub router, then it can receive updates from the neighbors, but it cannot exchange updates which is coming from one neighbor with another neighbor. It cannot share those updates which are coming from one neighbor with another neighbor. Means it will work as a stub router, so it will keep on to receive updates coming from their neighbors, and also that router can also advertise its own network information towards its neighbor. Like for an example, if you move on R6, I know that R6 is the edge router. Remember that in EIGRP you will configure only and only edge router as a stub routers. So now if you move on R6, let's say that it is an edge router. So router EIGRP is what? CC IE address family IPv4 autonomous system is 100, and then say EIGRP stub. In topology base, in topology mode, you will not configure this EIGRP stub. Inside address family mode itself, you can configure EIGRP stub. Now, when you configure EIGRP stub, remember that it will add two different keywords here. One, connected, and summary. Let me show you. Do show run pipe section router EIGRP. It's not it. And once you have configured this router as a stub router, now its neighbors will never be able to send query messages towards this router R6. To confirm it, you move on R4 and you say show IP EIGRP neighbor detail. What is it saying? Suppressing queries. What does it mean? That it will never send any query message towards this router. So now once you have configured any router as a stub router, it will never receive any query message from that specific, from its neighbors. So now either R4 or R5 will not be able to transmit any query message in the direction of R6, because they know very well that this router is configured as a stub router. This neighbor is advertising itself as a stub router, and also it is advertising only connected and summary prefixes, summary routes. Like if you have configured any summary address on R6, then it will keep on to advertise that summary address towards its neighbors and also its connected routes. That is why here on R4 you can still receive all 60 prefixes coming from R6. But if you wanna say, like on R6, you could also configure this command as well, router EIGRP this time it will keep on to receive only, it will never advertise its own information towards any other neighbor now. So you move on R5, show IP EIGRP topology, show IP EIGRP neighbor detail. What is it saying? And suppressing. This time you cannot find 60 prefixes here.
R1 पे हमारे पास में कुछ राउट है, कनेक्टेड राउट है। अब इसमें से कोई भी डाल जाएगा तो ये क्वेरी सेंड करेगा R2 के पास और R3 के पास। तो उसका बेनिफिट क्या है? क्योंकि उसके हिसाब से तो ये डायरेक्टली कनेक्टेड है, तो ये कहाँ से जोड़ने को?
But you said that on R1, right? It takes a decision based on topology table. In topology table, it was having successor, right? There was no feasible successor. That's all. And who said that, okay, if it is learning it from here or it is directly connected, then it cannot learn the same prefixes from someone else? Might be that you are having same prefixes available on two different routers and both of them are advertising, so I can receive from both neighbors. Like there are two ISP routers, I'm receiving same internet routes from both routers now. I get your point? So it is something like that. And remember, EIGRP will always take decision based on its topology table, not based on routing table. I mean, like in topology table, if there is no feasible successor and successor has gone down, it will immediately generate a query message. Have you understood it or not? Hello, Vipin, are you okay with it? So if you are having any problem with it, please let me know. Otherwise, I have taught you everything related to named mode as well. And I think so that you can also configure like leak map as well. I hope that you understand the minimal leak map in stub routing. Like for an example, you have said, for an example, you are on R6 now. Let me do one thing. Let me shut down the link in between R5 and R4. You understand? R5 and R3 actually. So move on R5 now. And on R5, I'm going to shut down FA0Y1. So this time, now R5 can receive 10 prefixes coming from R6 only. So IP route, does it have? Nothing. You know why? Because on R6 I configured only receive only, right? So you do one thing. This time say only EIGRP stub. So again it will be connected and summary. So this time you will find that on R5 you can get 60s prefixes but not 10s prefix. Not 10s prefixes, because R6 cannot exchange routes in between two neighbors now, because R6 has been configured as a stub router now. If you want that R6 should send 10s prefixes towards R5, then you can use link map, like in this way. Access list 1 commit 10.1.0.0.0.0.7. And then say route map leak, it is already commit 10. Match IP address is what, and then router EIGRP is what, CC IE address family IPv4 autonomous system is 100, and then say EIGRP stub, and then you can say, or you could also say connected only if you don't want to allow summary addresses to if you do not want to allow this R6 to advertise summary addresses, summary networks in the direction of R4 as well as R5. So say EIGRP stub connected, leak map name was. So this time you will see that on R5 you will also get 10s prefix. Are you getting my point or not?
Yes.
So this is the uses of leak map, so that you can leak prefixes in between two neighbors. So that's the only uses of stub routing here. The main concept of stub routing is what, that your neighbor will never transmit query messages towards you. So sometimes, let's say that you are using hub and spoke topology. Let's say this is hub router and there are some spokes, spoke 2, spoke 3, spoke 4, and all of them are connected with the hub. Now in case if any network goes down on spoke 1, it will send a query message to hub, and hub will send it towards all spokes, all other spokes. Is it really feasible, or is it really good to send this query in the direction of all other spokes? We know very well that these all spokes will never have the information of other spokes. Like for an example, spoke 1 will never be having an information about spoke 2 or spoke 3. We cannot reach spoke 2, spoke 3 by spoke 1. Of course, it is not possible. So why is it necessary, or why is it good for hub to send this query message in the direction of spokes? Of course, it is not good. And to prevent your network from these type of problems, of course, we can configure all spokes as a stub, so that hub will never send any query message in the direction of any spoke. So I'll define all spokes as a stub router. So if you are having hub and spoke topology, then on all spoke routers you will configure this stub routing. You will enable this stub routing. Have you understood it now? So is there any problem? So in this way you can configure stub routing, and this is all about that how can we configure this EIGRP in named mode. And one more thing I would like to tell you, that it is not always necessary to use or it is not always mandatory to use named mode on both routers to form neighborship. No. On one router if you are running named mode, and on another router if you are running classic mode, then also they can form neighborship. They have backward compatibility actually. Named mode and classic mode have backward compatibility.
What is the metric calculation formula for this?
It will be 32 bits long actually.
Okay.
And whenever they will move into that, then it will it will calculate its metric as 64 bits long. Whenever prefixes will move from named mode into classic mode, metric will be calculated as 32 bit long, and whenever routes will go from classic mode into named mode, then accordingly they will calculate their metric. So if you are having any topic left in EIGRP named mode, please let me know. From my side, I have covered all of the topics of named mode. EIGRP named mode now.
Sir.
Do one more thing. Like we can move under topology based mode. Router EIGRP CCIE address family IPv4 autonomous system is 100 topology base, and then I think we have covered all these commands. Is not it? And if you come out from here, then also you can put.
So Russian the default value is 0 in case it's 2.
Yes, by default it is 0. Even I can show you. Show IP protocols. This is named mode. In classic mode, yes. Non-stop forwarding. What? My God. This NSF non-stop forwarding is a feature of 4500 series of switches or 6500 series of switches. Like if you are having more than 2 supervisor engines on a single switch, then you have redundancy modes too over there, like RPR, RPR plus, SSO, stateful switchover. In case of SSO, your failover time is less than 1 second. In that case, NSF will be in use, non-stop forwarding, in which it will copy the SAF table from one soup card to another soup card. So for that purpose here, we are having this NSF aware routing. So if your device supports NSF, it means over there you have to implement NSF aware routing. So nowadays it is by default enabled.
एक बुक भी कुछ EIGRP OTP
EIGRP
OTP.
OTP. EIGRP OTP is mentioned in your book, but in your book itself it is also mentioned that it is out of scope as well.
Full form क्या है?
I don't remember.
और क्या करते हैं?
So you do one thing now, go through this EIGRP with the help of your book, and if you find anything, any topic, any terminology which we didn't cover here, then you can come to me and ask me, right, later on as well. Then I can explain it to you that okay, this is the meaning of it. However, now what I think that I have covered all of the topics which are given in your book, not in your book actually, according to the Cisco blueprint. Yeah, according to the CCR syllabus, I have covered all the topics of EIGRP now.
So guys, so this is the last video of the topic, that's EIGRP. We are done with the topic. I hope you learned something good about this topic and you have better understanding of the EIGRP now. So we'll be coming with few more videos of different topics. So till then, thank you so much. If you like my videos, please subscribe my channel. That's ARC underscore tutorial. Thank you so much guys. See you next time.